The National Electrical Code, or NEC, doesn't specifically address the installation of pneumatic tubing with low-voltage wiring in the same raceway. However, several sections may be relevant. Article 300.8 requires that wiring of different systems, such as communications and power, be separated by barriers or sleeves, unless specifically permitted elsewhere in the NEC. Article 600.8 specifically prohibits the installation of cables rated over 600 volts in the same raceway as cables rated for lower voltages. Article 800.52 permits the installation of power-limited fire alarm cables in the same raceway as other wiring, including pneumatic tubing. Now let's consider the application to pneumatic tubing. Pneumatic tubing is typically used to transmit compressed air for control purposes, and importantly, it does not carry electrical current. Therefore, it would not be considered a cable as defined by the NEC. However, it could be considered another system under Article 300.8 since it is not a power, communications, or signaling system. Let's discuss arguments for allowing the installation. Firstly, since pneumatic tubing does not carry electrical current, it does not pose the same safety concerns as high-voltage cables covered by Article 600.8. Secondly, in many temperature control systems, pneumatic tubing is an integral part of the system and often goes to the same device or control panel. Thirdly, prefabricated control panels that contain both DDC signals and pneumatic connections are widely used and have been deemed safe. In conclusion, based on the analysis, it is reasonable to argue that the installation of pneumatic tubing with low-voltage wiring in the same raceway is permitted under the NEC, provided that several conditions are met. Firstly, the pneumatic tubing is part of an integral temperature control system. Secondly, the tubing does not impede access to other wiring in the raceway. Thirdly, the installation is in accordance with good engineering practices and does not create any safety hazards. Considering recommendations to avoid any potential disputes with the authority having jurisdiction, or ORG, it is always advisable to consult with a local electrical inspector before proceeding with such an installation. It's important to understand the reasoning behind the code. The primary concern is safety, and the NEC aims to prevent situations where different voltage levels or systems could create hazards. In the case of pneumatic tubing, the risk is generally considered low because it doesn't conduct electricity. However, the code also emphasizes maintaining clear and accessible wiring within raceways. Overcrowding or poorly organized installations can make troubleshooting and maintenance difficult, increasing the risk of accidental contact with live wires. Furthermore, it is important to consider the specific type of pneumatic tubing being used. Some tubing may be made of conductive materials or contain metallic components which could introduce electrical hazards if not properly grounded. Therefore, it's essential to ensure that the tubing is non-conductive or appropriately grounded to prevent any potential electrical faults. When evaluating the permissibility of installing pneumatic tubing with low-voltage wiring, it's crucial to consider the overall design and installation practices. Factors such as the size and type of raceway, the spacing between wires and tubing, and the use of appropriate connectors and fittings can all impact the safety and functionality of the system. It's also important to note that the NEC is a living document that is updated regularly to reflect changes in technology and industry best practices. Therefore, it's essential to stay informed about the latest revisions and interpretations of the code to ensure compliance and maintain a safe electrical system. The NEC provides specific guidelines for the installation of different types of wiring and equipment, including minimum wire sizes, conduit fill capacities, and grounding requirements. These guidelines are designed to prevent overheating, short circuits, and other electrical hazards. In addition to the NEC, local codes and regulations may also apply to electrical installations. These local codes may be more stringent than the NEC and may address specific concerns related to the local environment or infrastructure. Therefore, it's important to consult with local authorities to ensure compliance with all applicable codes and regulations. When installing electrical wiring and equipment, it's essential to follow proper safety procedures to prevent electrical shock and other injuries. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. It's also important to use properly insulated tools and equipment and to avoid working in wet or damp environments. Electrical installation should be performed by qualified and licensed electricians who have the knowledge and experience to ensure that the work is done safely and in accordance with applicable codes and regulations. Using unqualified individuals to perform electrical work can increase the risk of electrical hazards and may result in code violations and fines. Regular inspections and maintenance are essential to ensure the continued safety and reliability of electrical systems. These inspections should be performed by qualified professionals who can identify potential problems and recommend appropriate solutions. Maintenance activities may include tightening connections, replacing worn or damaged components, and testing the system to ensure that it is operating properly. Another area to consider is the potential for electromagnetic interference or EMI. Although pneumatic tubing itself doesn't generate EMI, nearby electrical wiring can. If the low voltage wiring is carrying sensitive signals, the proximity to other electrical conductors could introduce noise or interference affecting the performance of the control system. In such cases, shielded cables or separation techniques may be necessary to minimize EMI. The environment in which the installation takes place also plays a role. In harsh environments with extreme temperatures, humidity, or corrosive substances, the materials used for both the pneumatic tubing and the electrical wiring must be suitable for those conditions. Using inappropriate materials can lead to premature failure, posing safety risks and requiring costly repairs. When evaluating the safety of combining pneumatic tubing and low-voltage wiring, consider the potential consequences of a failure. For example, if the pneumatic tubing were to leak or rupture, could the escaping air or fluid damage the electrical wiring or create a hazardous situation? Similarly, if the electrical wiring were to fail, could it ignite the pneumatic tubing or create a shock hazard for anyone working on the system? These potential failure modes should be analyzed and addressed in the design and installation process. Furthermore, documentation is key. Maintain detailed records of the installation, including drawings, specifications, and test results. This documentation can be valuable for future troubleshooting, maintenance, and upgrades. It also provides evidence of compliance with applicable codes and standards, which can be important for insurance purposes or in the event of an incident. When dealing with complex installations involving multiple systems, it's always a good idea to consult with experienced engineers and other experts. They can provide valuable insights and guidance, helping to ensure that the installation is safe, reliable, and compliant with all applicable requirements. In the context of control panels, where DDC signals and pneumatic connections are often found together, manufacturers typically design and test their panels to meet specific safety standards. These standards may address the separation and isolation of different systems within the panel, as well as the overall safety of the panel as a whole. When using prefabricated control panels, it's important to verify that they are certified by a recognized testing laboratory, such as Underwriters Laboratories, or Canadian Standards Association, or CSA. Certification indicates that the panel has been tested and found to comply with applicable safety standards. Finally, remember that the interpretation of the NEC can be subjective and may vary depending on the AHJ. Therefore, it's always best to communicate with the local electrical inspector early in the planning process to get their input and ensure that the installation will be approved. The goal is to find a solution that meets the intent of the code while also addressing the specific needs of the application. In some cases, it may be necessary to seek a formal interpretation from the NEC committee to clarify a particular code requirement. The NEC committee provides interpretations to help resolve ambiguities and ensure consistent application of the code. This process can be time-consuming, but it can be valuable in resolving disputes and ensuring compliance. In summary, while the NEC doesn't explicitly prohibit the installation of pneumatic tubing with low-voltage wiring in the same raceway, it's important to carefully consider the applicable code requirements, potential safety hazards, and best engineering practices. By taking a thorough and proactive approach, you can ensure that the installation is safe, reliable, and compliant with all applicable regulations. Also consider the impact of future modifications or additions to the system. If the system is likely to be expanded or modified in the future, it's important to design the installation in a way that allows for easy access and flexibility. This may involve using larger raceways or providing additional pull boxes to accommodate future wiring. The selection of appropriate connectors and fittings is also crucial for ensuring a safe and reliable electrical system. Use connectors and fittings that are specifically designed for the type of wiring and raceway being used, and follow the manufacturer's instructions for installation. Improperly installed connectors and fittings can lead to loose connections, overheating, and other electrical hazards. Furthermore, be aware of the potential for corrosion. In certain environments, such as those with high humidity or exposure to corrosive chemicals, electrical wiring and equipment can corrode over time. This corrosion can weaken connections, reduce insulation resistance, and create electrical hazards. To prevent corrosion, use corrosion-resistant materials and coatings, and regularly inspect the system for signs of corrosion. When working with electrical wiring, it's important to use proper wire management techniques. This includes bundling wires together, securing them with cable ties or straps, and routing them in a neat and organized manner. Proper wire management can prevent tangling, reduce stress on connections, and make it easier to troubleshoot and maintain the system. Consider the use of surge protection devices. Surge protection devices can protect sensitive electronic equipment from damage caused by voltage surges, such as those caused by lightning strikes or power grid disturbances. Surge protection devices should be installed at the service entrance and at any point where sensitive equipment is connected to the electrical system. Finally, remember that electrical safety is everyone's responsibility. If you see something that doesn't look right, don't hesitate to report it to a qualified electrician. By working together, we can create a safe and reliable electrical environment for everyone. Ensure that all electrical panels and enclosures are properly labeled. Labeling should clearly identify the circuits and equipment served by each panel or enclosure. This can help prevent accidental contact with live circuits and make it easier to troubleshoot problems. Consider the use of arc fault circuit interrupters, or ASIs. ASIs are designed to detect arc faults, which are a common cause of electrical fires. ASIs can trip a circuit breaker before a fire starts, providing an additional layer of protection. Use ground fault circuit interrupters, or GFCIs, in wet or damp locations. GFCIs are designed to detect ground faults, which can cause electrical shock. GFCIs can trip a circuit breaker in milliseconds, protecting people from serious injury. Be aware of the potential for static electricity. Static electricity can build up on non-conductive surfaces and discharge to nearby objects, creating a spark. In certain environments, such as those with flammable materials, this spark can ignite a fire. To prevent static electricity, use anti-static mask sprays and clothing. Remember to properly dispose of electrical waste. Electrical waste, such as batteries, fluorescent lamps, and electronic equipment, can contain hazardous materials that can pollute the environment. Dispose of electrical waste properly by recycling it or taking it to a designated collection facility. Regularly test emergency lighting systems. Emergency lighting systems are designed to provide illumination during power outages. These systems should be tested regularly to ensure that they are functioning properly and that the batteries are fully charged. Use only approved electrical equipment. Approved electrical equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Using unapproved equipment can increase the risk of electrical hazards. Be aware of the potential for rodents and other pests to damage electrical wiring. Rodents can chew through electrical insulation, creating a shock hazard or causing a fire. To prevent rodent damage, seal any openings in walls or floors and use rodent-resistant wiring. Consider the use of energy-efficient lighting. Energy-efficient lighting, such as LED lighting, can save energy and reduce operating costs. Energy-efficient lighting also produces less heat, which can reduce the load on air conditioning systems. Finally, remember that electrical safety is an ongoing process. Stay informed about the latest safety standards and best practices, and regularly inspect and maintain your electrical system to ensure that it is operating safely and efficiently.